So this is the last section from this unit on just a quick overview of geometry. And the last thing we're going to talk about is three-dimensional figures. So we started off this unit, we talked about points, lines, planes, and angles, and we did some fun things with that and joining things together and parallel lines. And then we talked about triangles and then polygons, two-dimensional figures. We just finished up with circles, two-dimensional figures. So volume and surface area refers to three-dimensional figures. So starting off, a word that you may or may not have heard before is what's called a polyhedron. Spelled P-O-L-Y-H-E-D-R-O-N, polyhedron. A polyhedron is a three-dimensional closed figure formed by the union of polygons. So if you take different polygons, triangles, parallelograms, whatever, pentagons, anything like that, and you glue them together, you can make three-dimensional figures. And there's all sorts of fun geometry. I wish we had time to go through all the fun ways that you can join these things and the properties they have and all sorts of fun stuff. So if you ever Google about that, there's some good stuff, but we're just going to go really super brief overview of some basic figures. Okay, there's two types of figures made out of polygons that we're going to talk about in this class. The first one is what's called a prism. A prism has congruent polygon bases. That means the top and the bottom are going to be the same, and each side's a rectangle. So that means I can use any possible figure I want for the top and bottom. We are going to stick in this class with the figures that we know how to work with, okay, like parallelograms and stuff. So I am not the best artist. Okay, I'm going to do my best for you right here to draw some prisms. So here's a prism with a triangle as the top. So here's my triangle as the top. And by the definition of the prism, all the sides are just rectangles. So I'm going to just drop these sides down. I'm going to do a little dotted one for perspective. That's one thing I do remember from middle school art class. Oh, I should have done perspective for the back ones too. So sorry. Again, art is not my forte, unfortunately. I admire anyone who does have that ability. Here is a box, which is just a prism that has a square or a rectangle or something. So here is a rectangular prism. Again, trying my best. And we're going to, each side is also going to be a rectangle. And I don't know that I'm going to go for perspective on that one because it kind of goofed me up. Now, we're not going to talk much about it because we don't know how necessarily to do the area of it, but we could do something that has like an octagon or a pentagon. Let's do pentagon. Let's not get too aggressive here. So there's a pentagon, and then each side would be a rectangle. So you can have, my point here is you can have any straight-sided figure be the top or bottom, or if it was oriented different, left or right. But I can only draw these things top to bottom. You would be testing my artistic ability too much. Now, again, because I'm trying to make these things easier to remember, even if you do have a formula sheet, a prism, this next thing is not necessarily a prism, but it's going to follow the same pattern. If I have a circle as the top and the bottom of this. Does anyone know what it's called when you have a circle as the top and the bottom of this? Yeah, so a cylinder is not the exact same thing as a prism, but for our purposes in this class, it's going to follow the same pattern. That's why I mention it right here. We'll come back and we're going to talk about how do I find the volume of prisms. And it's all going to be the same pattern. But before we do that, the other type of three-dimensional figure we're going to talk about here is called a pyramid. Now, unlike a prism has the same polygon as the top and the bottom. A pyramid has a single polygon that's called the base. And the sides are triangles that meet at a common point at the top, or left or right, or whatever orientation. I can only draw pyramids upside down. Okay, I'm sorry. I know it's tough to be in my class. So here's a pyramid with a kind of a rectangle as the base. And then what you have is all of these sides are triangles that meet at a common vertex. Okay, so that is a pyramid with a rectangle as the base. As I said, I can only draw them upside down for whatever reason. Here's one with a triangle as the base. So here we go. Here's a triangle that will form my top. And now I'm going to take the sides. The sides are going to be triangles that look something like that. So that's what a pyramid is. And again, you can have any polygon. You could have an octagon. You could have a dodecahedron. Whatever could be the bottom. And then all the sides go to a point. Now, just like I did for our prism, this again is not technically a pyramid, but it follows the same pattern. If I have a circle as the base, does anyone know, if you've gotten ice cream lately, does anyone know what it's called when you have a circle as your base? It's a cone, yes. Again, it's different than a pyramid, but for our purposes, it's going to follow the same sort of pattern. And what do you mean, Perkster, by the pattern? That's a great question. So we're going to find the volume of these things, and the volume is the space that's inside, the three-dimensional space. In our room right here, the volume would be the air that's in the room. Okay, it's a three-dimensional quantity. So our volume, the volume of a prism. Remember, prism has the same polygon, top and bottom, rectangles form the sides. The way you find the volume of any prism is you have the area of the base times the height, meaning the difference between the two polygons. The area of the base times the height. Well, the good news for us is we just talked about area. So all those area formulas that you know are just are applicable times the height. So if you don't want to use the formula sheet, this should be nice and easy to remember just from what you already know. So the volume of a prism is the area of the base times the height. If you were to read our book, the symbols that our book uses are capital letters to indicate we're in 3 dimensions. So capital B would be the area of the base. Unlike lowercase b, which is like the base in a parallelogram or a triangle, and then times capital H for the height between the bases. If you don't want to remember it like that, totally fine. So here's my first example. We're going to find the volume of this prism right here. Now, again, I am a formula minimalist. That's why I have not given you a formula for each of the different things. I've just told you it's the area of the base times the height. So this one, example 1, what is the base of this prism? What kind of figure is it? The base is not a rectangle. Remember, the base of a prism is the polygon that is the same on both sides. Now, this one is not oriented up and down. This one's oriented front to back. It's a triangle this time. Yes. So the volume is the area of the base, capital B, times the height, the distance between the two bases. Now, if I was to give you a formula, here's what it would be for the volume of a triangular prism. What's the area of a triangle? That's one you do have to know. What's the area of a triangle? 1/2 times the base of the triangle, lowercase b, times the height of the triangle, lowercase h. Well, there it is. There's the formula. If you're dying for more formulas to memorize, there's the formula for a triangular prism right there. Okay. All right, so let me go ahead and plug and chug here. And once you got that down, that's all it is. So I've got 1/2. What is the base of the triangle, the lowercase b? 6. Yep. What's the height of the triangle, the lowercase h? 6 again. And then what's the height? What's the distance between those two triangular bases? 9. Yep. And so I'm just going to go ahead and multiply those things together. I've got a half times 6 times 6 times 9. So 0.5 times 6 times 6 times 9. And that equals 162. And what are my units on this one for volume? Meters what? Yes, plain old meters. Remember, plain old meters is a distance. That's perimeter. Meters squared, that is an area. Meters cubed is the three-dimensional unit. That indicates volume. If you got a question, ask it. If not, exercise 1 is a box. It doesn't matter for a box. It doesn't matter what sides you use as the bases because they're all, but just so that we're all doing the same thing, let's use the top and the bottom of this one as our bases. If you don't, you'll have the same numbers multiplied together, just in a different order. Okay, so don't freak out about it. But I'm going to do this considering the top and the bottom as my bases. Okay, so the volume of this, the volume of any prism is the area of the base, capital B, times the height, capital H. So the base here is a rectangle. How do you find the area of a rectangle? What do you do? Base times height or length times width, whatever, however you got that coded into your memory banks. What is, of my bottom here, what is the base times height or the length times width? What are those dimensions? Again, that would work, so you're not wrong. Okay, so but I'm just looking at the bottom rectangle right here. And so the bottom rectangle is going to be 8 times 2 are my dimensions down there, and then times the height of the prism, the distance between the top and the bottom is going to be 4. But again, a box is a unique one because you can take any pair of sides and consider it the bases. Okay, because they're all equal on either side. For a triangular prism, as we said before, it has to be the triangles, because by definition, a prism is the same polygon on two sides, and then all the other sides are rectangles, which that applies to this thing right here. Okay, so no matter what you did, though, you're going to be multiplying 8 times 2 times 4, or 8 times 4 times 2. You're just going to have it in a different order, which is fine. Okay, you're not wrong. Don't change it. So 8 times 2 is 16 times 4, that is 64. And what are my units on this right here? Perfect. Appreciate it. Units matter. Don't forget your units. Before I turn the page, we doing okay? Everybody keeping up? Yeah. Volume is always a cubic unit. Great question. Okay, there's 3 dimensions to volume: a length, a width, a height. In this room right here, I can go left, right, front, back, and if my knees had the ability, I could jump up and down. Okay, so there's 3 dimensions of movement. In area, when you're putting down the carpet, there's only 2 dimensions of movement: left and right, or forward and backwards. And then if you're doing perimeter, there's only 1 dimension of movement. Okay, that is either forwards or backwards along the perimeter. Okay, so great question. It's good to keep that not nailed down. All right, exercise 2. I've just given you another prism. This time the bases of the prisms are trapezoids. So go ahead and determine the volume of that prism right there, please. All right, so this volume is the area of the base times the height. I told you the base is a trapezoid. Who remembers what is the area of a trapezoid? How do you find that? Okay, so in case you didn't hear it, she said B1 plus B2 divided by 2, which I called in class the average of the bases, just as a way to remember it, times the height of the trapezoid. So perfect. So let's do that. So to find the area of the base, it's going to be B1 plus B2. What dimensions represent the bases of the trapezoid? Yep, 8 plus 12 divided by 2. And then what's the height of the trapezoid? What's the distance between those two bases? 10? Yep. Okay, so that right there, I'm just going to underline this so that when you're looking at your notes later, right there, what I'm underlining, that's the area of the trapezoid. It's the area of the base. Now, times the height of the whole prism. The distance, what's the distance between the top trapezoid and the bottom trapezoid? That is what? 24. Yes, there you go. And now it's just a matter of once you got the numbers, it's just throwing it down into your calculator and determining what the result is. So 8 plus 12, that is 20. 20 divided by 2 is 10. So I've got 10 times 10 times 24. That is going to be 2,400. And then humor me, what are the units of this right here? Inches, I heard. Cube, there you go. Three-dimensional, since we found a volume. Perfect. All right, one more prism. Again, this next figure would not be categorized geometrically as a prism, but its volume works in the exact same way as a prism. It's the area of the base times the height. So give this one a try for the cylinder, please. So the volume of any prism, including a cylinder in that, is going to be the area of the base times the height. And we just saw a few minutes ago that the area of a circle is pi times r squared. In this case, r is 6, so pi times 6 squared times the height of the cylinder. And in this case, the height of the cylinder is 24. I'm just going to give the approximate answer. In my math lab, it might ask for the answer in terms of pi. You know what to do for that. We were just doing it a little while ago for circles. And so what we've got here when I go and do this is I've got 6 squared is 36 times 24 times pi. I'm going to round to the 10th on this. And so that is going to be 2,714.3. And then last but not least, the units of this volume are going to be what? Inches cubed. We doing okay? Okay, I know this is a lot to absorb, trying to go through at a decent pace. That is prisms. That's what to do when the top and bottom or left and right are the same figure, the same polygon, and all the sides are rectangles. Okay, now the other thing I told you, the other three-dimensional figure is pyramids. Pyramids, their volume, I think it's an interesting relationship. The volume of a pyramid now is not just area of the base times the height of the pyramid, it is 1/3 the area of the base times the height. And in symbols, our book would say 1/3 times capital B times capital H. I just think that's, to me, that's really mathematically interesting. That, you know, if you look at example 2, and we've got a pyramid with a 12 by 12 base. If I had a cube that was 12 by 12 by 12, it's just interesting to me that exactly 3 of the pyramids would fit inside the cube. It just seems like wild that it would be that exact of an amount. It is. And I find that fascinating. You might not find it fascinating, but that's okay. I'm the one talking, so I get to find whatever I want fascinating. Okay, so here we go. The example 2, we're going to find the volume of this pyramid that has a square as its base. So the volume of this is 1/3 times the area of the base times the height of the pyramid, meaning the distance up to the tippy top. So that's 1/3. Since the base is a parallelogram or a rectangle or a square, whatever you want to call it, it's all the same thing for this one. The area of the base is 12 times 12. Again, I'm just going to underline that so when you're looking back at your notes later, you know that that right there is the area of the base. And then times the height of the pyramid. So the height is the distance from that base up to the very top, and that in this case is 15. So when I throw that into my calculator, I've got 1/3 of 12, or 12 divided by 3, that is 4 times 12 times 15, and that turns out to be 720. And again, this is a volume. My units are all centimeters, so that is centimeters cubed. If you got anything you need from me, please ask it. You've been in this class long enough. You know that you can ask whatever questions you need to. Go ahead and flip the page. Giving you another pyramid. This pyramid has a triangle, in fact, a right triangle as the base. Okay, so go ahead and find the volume of that pyramid, please. All right, so the volume of any pyramid is 1/3 the area of the base, which in this case is a triangle, times the height, meaning the distance from that base up to the pointy part. So in this case, that is 1/3. The area of a triangle is 1/2 the base of the triangle. Now, this is a right triangle, so the base and the height of this triangle are just the sides. So I'll just use 15 as the base and then 9 as the height of that. Again, I'm just going to put a little box around that just so that you know that that's the area of the triangle. So that I just want you to know when you're looking back at your notes later, where we got those things from. And then the height of the pyramid from that triangle up to the pointy part is 13. All those dimensions are in feet. Okay, I didn't have to do any converting. So I'm pretty straightforward problem once you remember the area of a triangle. And so when I do that, I've got 13 times 9 times 15, and then I'm dividing by 2, and then I'm dividing by 3, and that turns out to be 292.5, and the units are feet cubed. Any questions? Anything mysterious? A fraction's just division. So I did 13 times 9 times 15, and then I divided by 2, since it's in the denominator. And then I divided by 3, since it's in the denominator. It's just like when we were doing unit fractions. If something's in the denominator, it just means divide by that. If something's in the numerator, if there was like a 2 up there, you would multiply by it. Okay. All right, great. All right, one more. This is another, again, this cone wouldn't exactly be classified as a pyramid, but its volume follows the same pattern. So find the volume of the cone, please. I'm just going to plug and chug. If you're still working, keep working. Let's compare notes. So this is 1/3. The base is a circle. The area of a circle, which we've been practicing today, is pi times r squared. So pi times the radius, which is 3 squared. And then the height of the cone is 14. So that pi times 3 squared in there, if you need to, circle that and notate that as the area of the circle. And then I'm just going to go ahead now. I'm not going to do the exact answer in terms of pi. I'm just going to go ahead and do the approximation. So what I've got here when I do this is I've got 14 times 3 squared, which is 9 times pi. And then I take that, and since that 3 is in the denominator, I'm going to divide by 3. And that gives me 131.946. So that is 131.9 centimeters cubed. All right, we're rolling to the finish line of what we're going to do. So if you got any questions, let me know. There's one other figure, and then we've got one other figure we're going to talk about the volume of, and then we'll finish up talking surface area in this section. So we've talked about prisms, we've talked about pyramids. The last 3-dimensional figure we're going to concern ourselves with in this class, it's called a sphere. Hey, I'm sure you've seen a sphere, you're familiar with sphere. A sphere's definition is super similar, except for one word, to that of a circle. A sphere is a set of points in space that are equidistant from a fixed center point. Remember, a circle was the set of points in a plane in 2 dimensions. A sphere is the set of points in 3 dimensions that are all the same distance from a fixed center point, the reference point. The volume of a sphere is 4/3 times pi times r cubed. And so this is just straight plug and chug. So go ahead, exercise 6, right below, there is a maroon sphere. The diameter is 9 centimeters. Go ahead and find the volume of that for me, please. All right, so I'm going to plug and chug here for this sphere. So the volume is 4/3 times pi times r cubed. And so the only thing that is really up for question here is, what's the radius of this sphere? Yeah, 4.5 centimeters, and we'll cube that. So it's just a calculator problem. I'm going to take 4.5, I'm going to multiply it times itself 3 times, I'm going to cube it, so 4.5 cubed, that turns out to be 91.125. I'm going to multiply that times pi, and that turns out to be a gross number. Then I'm going to take that times 4, and then I'm going to divide by 3. The 4's in the top, the 3's in the bottom. And so that gives me 381.7035. So 381.7. And my units, since it is volume, are cubic centimeters. You okay with that? Don't let me move on if you're not okay with it. Okay, we're doing great on time here. So we're going to flip the page. And the last little bit of, I don't stress this too much. The last little bit that we're talking about here is surface area. And surface area just means, okay, if you were a bug walking on a 3-dimensional figure, how much area is there? So we're going to start with the sphere, and then we're going to talk about prisms, and then that is going to be all she wrote for this section. So a sphere, straightforward. A sphere, the surface area, which I'm going to abbreviate SA for surface area because I'm super clever. Okay, the surface area of a sphere is 4 times pi times r squared. Basically, it's 4 times the area of a circle. So once you've written down, again, it's just a plug and chug. You got the formula sheet that you can use in this class. So there's nothing really I can enlighten you on. So go ahead and do exercise 7. Find the surface area of the sphere from the previous problem. Okay, the surface area of a sphere is just 4 times pi times r squared. So that is 4 times pi. And then you have already told me that the r for this is 4.5 squared. So again, it's just going into your calculator. It's not super fun. It's just a matter of plugging and chugging. So it's 4 times pi times 4.5 squared. So I'll multiply that twice. And I end up with 254.469. So I'm just going to round to that one decimal place like we've been doing this whole section. So 254.5. This is surface area. So what are the units going to be on this? Yep, square. So centimeters squared. Great. Excellent job. All right, 2 more problems and then you're done with me, and I know you're thankful for that. So here we go. Surface area of a prism. We're only gonna do prisms. We're not gonna do pyramids in here. I don't think it's worth doing. The surface area of a prism. All you do for the surface area of a prism is the surface area is equal to the sum of the areas of all the sides. There's no real great way to put it, unfortunately. So the good news for a prism is the prism has the same polygon on 2 sides. In the case of the problem you're going to do here in a minute, it's a triangle. The front and the back are a triangle. And then all the other sides are rectangles. So looking at this, before you go and do this prism, how many bases do we have? How many triangles are there? There's 2. Okay, so you need to add up that area twice, whatever it is. And then how many rectangles, as I go around this, how many rectangles are on this prism? Yeah, there's this one facing up. There's the one on the bottom that it's resting on, and then there's the one on the back facing away from us. There's 3 rectangles that you're going to find the area. So I'm going to give you a minute or two. I want you to find as many areas as you can. And then the last thing we're going to talk about is the special type of prism, a cylinder, and finding the surface area of that. All right, so just for time's sake, because I always promise not to keep you late, and I want to make sure we get that last problem in. So here we go. We're going to find the surface area of this thing right here. So the first thing I'm going to do is I'm just going to figure out the area of one of the triangles. I'm going to use A with a subscript triangle. The area of a triangle, this doesn't change from what we've talked about before, is 1/2 the base of the triangle times the height. The base of the triangle is 6. The height of the triangle is 6. So it's 1/2 6 times 6. So 1/2 of 6 is 3. 3 times 6 is 18 meters squared. And you told me that not only is there a front triangle, but there is a back triangle. So I'm just going to partition these out. However, you can keep this all straight. I'm going to say that's the front right there. And then I've got 18 meters squared is going to be the back triangle. You with me so far? Why I've got two of those. All right. Doesn't matter what order you do the rectangles in. Let me do the bottom one. Okay. So let's do the area of, I'm going to use BOT for bottom. Okay. The area of the bottom of this. What are the dimensions of that rectangle on the bottom? Yep, 6 and 9. Okay, 6 times 9. 6 times 9 is equal to 54 meters squared. I'm just realizing that there's one part of this problem that's a little bit, I wouldn't say hard, but there's a little extra work you got to do. I didn't realize it when I first gave it to you, but that's okay. Let's do the back side. Okay, this one over here that we can't see, the one that's facing away from us over there. So the area of the back, BAC for back. Okay, so what are the dimensions of the back side over there? Okay, 6 is this standing straight up, and then this dotted line right here is going to be 9. So it as well is 6 times 9 is 54 meters squared. And then the area of this angled side, so I'm just going to call that the top for lack of anything else. The top, this side is 9, but the part that I didn't realize at the beginning, I thought this was a little quicker. We need to figure out, I'm going to just trace it in blue. What is this length right here? Okay, well, this is just a way to review. What kind of triangle is that on the side? It's a right triangle. So I need to figure out what the hypotenuse of that triangle is. So remember the Pythagorean theorem. I'm going to come over here into my white space over here. One of the legs of that triangle is 6 squared. The other leg is 6 squared, and that equals, I don't know, squared, the side that we're looking for. That's 36 plus 36, that's 72, is equal to the hypotenuse, the side that I'm looking for, squared. And in my calculator, when I take the square root of that, so I just go into my calculator, I'm going to take the square root of 72, so the square root of 72 turns out to be 8.4852. I'll just call that 8.5. So I'm sorry I did that a little quick. I just used the Pythagorean theorem to get that missing side of that right triangle. That's 8.5, and 9 times 8.5 is 76.5 meters squared. So the surface area of that prism is just what I get when I add up those 5 things. The 18 plus the 18 plus the 54 plus 54 more plus 76.5. That equals 220.5 meters squared. All right, the last thing is the surface area of a cylinder. I think we've got just enough time for this. Here's what I would like you to do for me, please. There is a back page on this. I want you to rip off that back page. Okay, it's my demonstration page for you. If you're watching this on video, what I'm going to do with that back page that you might be holding is I am going to form it into a cylinder. So what I would like you to do is take that back page. This is to demonstrate how we're going to get the surface area of a cylinder. I want you to make a cylinder out of it, like this. So this is a cylinder, right? The demonstration here is this. How many rectangular sides does a cylinder have? Okay, so if this was like a can of soup or something, and I took a knife and how many rectangles do you get? You get one rectangle, right? This one rectangle makes the cylinder. Does that make sense? Okay. Like my triangular prism right here had 3 rectangular sides as we went around, but my cylinder only has 1, so it's this right here. Okay. So how do I find the area? What are the dimensions of this rectangle? Well, one of them, this right here on the side, is just the height of the cylinder. Would you agree with that? If I go ahead and roll it up, this one right here is the height of the cylinder. Does that make sense? Now here's the other one. This right here, this dimension. when I curl this back up, so if you're on the video, I'm looking at the base. When I curl this back up, what does that become? What is that distance? Not the diameter, but you're close. What do you call it when you go around a circle? It's called the what? So here's the base. Here's the base of this rectangle that forms the side of the cylinder. When I make the cylinder, watch what happens to the base. Watch what happens to this bottom side. When I make the cylinder again, what happens to that bottom side? It becomes a what? A circle. What is it called? What's the distance around a circle called? It's perimeter, okay, but circles get a fancy word for perimeter. It's called the circumference. Yes, the bottom of this rectangle is just the circumference of the circle. My attempt at that, and I'm sorry I had to do it quickly, was just to tell you where the surface area formula, which you got on your formula sheet, where that comes from. So the surface area of a cylinder goes like this. It's 2 times the area of the circle, because there's a top circle and there's a bottom circle, plus the area of the rectangular side. And because I'm out of room, the area of a circle is pi r squared, so it's 2 times pi r squared, 2 times the area of a circle. And then the rectangular side we just saw is just length times width. What was the length? The length was the circumference, okay? The length was 2 times pi times r. The length of the rectangle was just the circumference times the width of the rectangle, which is just capital H, the height of the cylinder. So it's circumference because that's the bottom of my cylinder. That was what I was trying to demonstrate by rolling up that piece of paper to show you that the bottom was just the circumference, that when I stretch it out. So real quick, I'm sorry, I'm going to go like 30 seconds over. Let me just plug and chug on this. This is the surface area of a cylinder. So I've got 2 times pi times r squared. The radius of the bottom is 2 squared. That's 2 times the area of the circle because there's a top and there's a bottom. And then the area of the big rectangular side is the circumference of the bottom, 2 times pi times 2, times the height of the whole cylinder, which is 12. So the first one, 2 times 2 is 4 times 2, that's 8 times pi, plus 12 times 2 is 24, times 2 more is 48 pi. When you add that up, it's 56 pi, and when you go to get the approximation in your calculator, 56 times pi is equal to 175.9 inches squared. I apologize that we had to go through that so quick. You have the example worked. I'm going to post the video if you need to watch it again. You've got homework to practice. Before we get started on the next unit in the next class, I will answer some questions. So if you want to do another surface area of a cylinder, we will do it then. So just let me know.